Okay, so this is part 2 of the video on ionic compounds, and this is going to be about naming binary, which means only 2 elements, ionic compounds. Okay, so the first step that we do is we write the cation and then the anion. So remember, the cation is the one that has a positive charge. So you're looking at the elements that are on the left side of the periodic table. And then the anion, and those are ones that are more to the right. Those are the ones that are more negatively charged. The cation is named after its parent element. So for example, Na plus is called sodium. And for the anion, we take the first part of the parent element's name, drop the ending, and add IDE. So chlorine, which has a -1 charge, would be chloride. Okay, so it's similar a little bit to what we did with covalent, but we don't worry anything about prefixes. There's no mono, di, tri, none of that. It's just the element for the first part. Second part is just going to be the element, and we take off the ending and put the IDE. Okay, so this one's a little bit easier. So some examples. This would be potassium chloride, calcium bromide. So you can see we have, let's get my pen here, we have potassium as our parent element. Chlorine, we take off the ending and add IDE to the end. Calcium, bromine, add the IDE at the end to make bromide. Okay, this one, strontium sulfide. So strontium, sulfur, take off the ending and add IDE. And the last one, we have aluminum, and then bromine, so this would be aluminum bromide. Again, these should not be capitalized, okay? We always want these lowercase, okay? So all lowercase. We don't capitalize the elements, okay? So when writing the formula from the name, we first write the ions, and then we do the formula, okay? So now we're looking at the other way. So instead of trying to balance it, we know its name, and we just have to figure out how much of each we have. So for example, magnesium chloride. We know that magnesium has a charge of 2+, chlorine is a -1. So we do our switch because they're not even. So that means that the 2 goes with the chlorine, the 1 from the chlorine goes with the magnesium, and we end up with magnesium chloride. Looks like this. Okay, some other examples. Aluminum oxide, magnesium phosphide, calcium oxide, and lithium sulfide. I want you to pause the video and try to do these, and then unpause and check your answers. Okay, so for aluminum oxide, we know aluminum, and we have oxide is oxygen. So oxygen is a 2-, aluminum is a 3+. So we're going to switcheroo, so that means we'll have aluminum with a 2O3. Okay, then we have magnesium and phosphide, which is phosphate. Magnesium is 2+. Phosphate is 3-. So we're going to switcheroo again. So that, I'm just going to draw an arrow here, gives us Mg3 and P2. Okay, calcium oxide. Calcium is a 2+. Oxide, just like up here, is a 2-. So since these ones balance out, it's just CaO. Lithium sulfide, which is sulfur. So lithium is a +1. Sulfur is a 2-. So for this one, they switch. So we have lithium 2 sulfide. Okay. All right. many cations in the FD blocks can have multiple charges, and so we differentiate the charge by using Roman numerals. Okay, so when we talk about FD blocks, we're talking about, I'm going to go back to the periodic table that we have in here. We're talking about the elements that are in this part. And we're talking about the elements that are here, those ones that I said we were going to leave alone for a bit. Okay. These are trickier because they don't follow this same pattern of the +1, +2, +3, +4, -4, -3, -2, -1. Okay, they can have different charges, and so we're going to use Roman numerals. So I'm going to show you what that looks like. Okay, sorry. I'm going to go back to where we left off. Okay. So here we go. Sorry about that. So with this one, so an example is magnesium chloride. Okay, magnesium. Oh, we did this already. Sorry. These were the ones we already went through. Here we go. All right. So Fe, if it has a +2 charge, we're going to do iron and then 2 Roman numerals. Okay. If it has a +3 charge, it is going to be iron 3. Okay, so the Roman numerals are going to tell us how many positive charges. These D and F block elements are going to be your anions. Okay, or I'm sorry, not your anions, your cations. So they're going to be those ones that have the positive charge. Okay. And these are the common cations. Okay, you do not need to memorize this. Okay. So you can see there's some 2s and 3s. And we'll talk about some of these kind of things as well in a bit. Okay, so we're going to do some examples. So our first one, we have MnF2. This would be manganese 2 fluoride. Okay, how do we know it's 2? Okay, we know that fluorine has a charge of -1, and there are 2 of them. So we know the total charge on this side is -2. So to balance it out, this has to be a +2, and that's why it has this 2. Okay, now we have lead sulfide. Okay. Again, sulfur is a 2-, so this has to be a 2+ to balance out. Cobalt 3 chloride. Now we're going to go the other way. So we know that cobalt is a 3, a negative. Cobalt is CO, so it's 3 negative. And then we have chlorine is a -1. So we need to have 3 of these. So we'd have COCl3. Nice. And then our last one is tin bromide. This one's going to have 4. Bromine has 1. So we're going to get tin, 1 of those, and 4 bromines. Oh, and that is where the notes are going to end. Now that you've learned how to kind of draw or illustrate the bonds and name them, there are some homework sheets for you to work on. There is one, it'll say Ionic bonding homework. It's just a one-sided, one-page sheet. And then there's another one where it's naming ionic compounds. And so that one's going to give you a bunch of compounds. It's two-sided, and you just write their names. And all of the answers will be on Schoology in the folder for ionic bonding. Please feel free to email me if you have questions or You can talk to me when you're back and we can go over anything you had questions on. Thanks.